Okay, we're just going to start off lab 1 or lesson 1, identifying security fundamentals. So let's click the OK. We're just going to Control Alt Delete. No, if it, oh, fuck me, dude. Okay, so first we need to log into the virtual server. In order to log into the virtual server, I would assume we need to, well, fucking do that. So in order to do that, though, I would assume you should just fucking log in the lab window. Okay, so select the commands icon in the title bar. Where the fuck is that? Control Alt Delete. Okay, I understand. I think I'm getting it here. So pass 1 2 3 4 is the login. Looks like we're good to go there. So we're gonna close this, and then since we're logged in, we're gonna click done. Now it's asking us to open the course data files right here. So we need to double click Simple Hasher to open it. Where is Simple Hasher? Just curious where Simple Hasher is. Okay, maybe we need to go into the C drive. So maybe we need to open run. So let's just open run. Oh, fuck me, dude. Why would Windows do that? Who the hell? Fucking A, man. They could not make this more fun, could they? Okay, so we're going into C09237 / identifying security fundamentals. And from here, we're just going to double click, right? So they want us to double click Simple Hasher to open it up. And once we do that, we should just be able to put security plus, click calculate hash, verify the hash result. The hashing algorithm transformed your input into a fixed length result, also known as a message digest. It is infeasible to reverse this result in order to identify your plain text input. Remove the plus from the input and select calculate hash. So obviously, yeah, it's going to just change this up. Verify that a minor change has produced a significantly different result. If similar input produced a similar hash result, then the hashing operation would be predictable. Therefore, hashing algorithms are designed so that even a minor change in input will lead to a major change in the result. Copy the security text and paste it into the enter input to hash text several times. Okay, so what it wants us to do is copy this and then do that. And then it wants us to do this several times. So we're just going to keep on doing that. So you can see that you just keep on having different hashes. So verify that the hash result is the same length despite the input being significantly longer. Oh, okay. So what it wanted was this maybe? Okay. I think that's what they were going for right there. So probably just wanting you to have security, and it just, they're highlighting that it's the same length here. So verify that the hash result is the same length. If the length of the input influenced the hash result, the hashing operation would be predictable. Therefore, hashing algorithms are designed to produce fixed length message digests. Close the Simple Hasher window. Okay, done. Review the answers using the knowledge icon. Considering that hashing is one way, and the hash is never reversed, what makes hashing a useful security technique? Because two parties can hash the same data and compare hashes to see if they match, hashing can be used for data verification in a variety of situations, including password authentication. Hashes of passwords, rather than the passwords themselves, can be sent between the two parties. A hash of a file or a hash code in an electronic message can be verified by both parties after information transfer. The encryption algorithm is the general rule, B. What are the distinctions between an encryption algorithm and a key? The encryption algorithm is the general rule or instruction set applied to the data to transform it to ciphertext. The key is the actual value used by the algorithm. A different key value results in different ciphertext. although the basic encryption process is the same. C, true or false. Session keys are static, meaning they are used over a long period of time. This is false. Session keys are not static, they are temporary. Another term for this is ephemeral, or I think I'm saying that word right, whatever the fuck. It's like EPHEMERAL. D as in Delta. What is a potential drawback of symmetric encryption? The need to share the key between the two parties creates the potential for key compromise or loss. E as in Echo. What makes public key encryption potentially secure? The private keys are not shared between the parties. F as in Foxtrot. Which cryptographic technique hides information in other media? And for example, you could hide important information in an image file. There's some different ways to hide, different keys or different important information inside of media. It's called steganography. And I think I'm saying that right, steganography. There's probably maybe a better way to pronounce it, but this is not English class. You're taking free security lessons on YouTube. Thank you.